Hello, this is Eric from UNC Charlotte. There are two main types of communications in MPI. Collectives involve all the processes of a communicator and are good for process symmetry. But in many applications, we need to be able to express communication between particular pair of processes. We will talk in particular about blocking two-sided point-to-point communications using MPI. The core goal is to create a communication between a pair of processes. The communication is said to be two-sided because both the sender and the receiver have to make an explicit function call. They actually make calls to different functions, which breaks process symmetry. As a result, it will be harder to program these communication patterns. But despite the harder to use than collectives, many applications express more naturally using point-to-point communications. Any application with spatial decompositions like engineering simulations or weather forecasting. Any manager-worker system like voting at home. Or any application that is structured to leverage specialized nodes with databases, I/O nodes, or GPU nodes. They will express better with point-to-point communications. The function used to send data is MPI send. It takes 6 parameters, and 3 identify where the data to send is, how many elements there are, and which type the data are. The destination is identified by the 4th parameter, which indicates the rank of the destination, and the 6th parameter, which indicates which communicator to use. The 5th parameter is a tag that is used to sort out what type of a message it is. You can think of it as the subject header for an email. The receiver calls MPI receive. The first 3 parameters indicate where to put the data once it is received, how much data can be received at most, and the type of data to receive. The 4th parameter indicates who is sending the message, and the 6th parameter indicates in which communicator the message is being sent. The receiver indicates that it is waiting on a message of a particular tag, identified by the 5th parameter. The last parameter is a pointer to an MPI status structure that will store metadata about the communication. Let's look at a simple example. Each process will create 2 vectors and will fill one of them with unique values. Then, rank 0 will send its vector to rank 1 of the world communicator using tag 1, 2, 3. Rank 1 will receive the data in vec2 from rank 0 using tag 1, 2, 3. The processes will print vec before the communication and vec2 after the communication. When running the code, we can see that vec2 has been left untouched for all processes beside rank 1. Rank 1 has the information from rank 0 stored inside of vec2. While the sender has to know all the information, what data to send and who to send it to, the receiver does not need to know everything. The receiver can choose to receive data from any source and to accept messages bearing any tag. Finally, the receiver only has to specify how much data it is ready to receive at most. But the receiver may need to know who the message was from once it is received, or how much data was received, or what tag the message had. That information can be obtained from the MPI status structure. The source and tag can be read directly, and the amount of data can be obtained by calling MPI getCount. Let's see how wildcards are used. In this example, all processes will send a piece of data to rank 0. Rank 0 makes 1 call to receive per rank. It does not specify the source of the message or its tag. It is also ready to receive more data than will be sent to it. When the code runs, we can see that the messages are received in an arbitrary order. Only the first entries of the vector are modified, since rank 0 was ready to receive more data than it was sent. Two-sided communication primitives enable to express data exchange between any 2 processes of an MPI application. While they break process symmetry in a way that collectives do not, they are useful for engineering applications and back-of-task systems.